Welcome back, students. Today, as we are already seeing, we will continue with the induction based transducers. So it is the induction based transducers. So already we have explained the induction based transducers works on the principle of self inductance or mutual inductance, and also I have explained you about the LVDT. What is LVDT? That is the linear variable differential transformer. Why it's called as a transformer? As I have explained, it is because it uses the principle of mutual induction. How the transformer works, it works on the same principle that it works on the principle of mutual inductance, and it has a primary coil and a secondary coil, and hence it's called as a transformer. I'll first draw the circuit for the linear variable circuit. You see, I'm not putting the shaft. Now you will understand why. You have as we have already seen, this is the primary coil, this is there, and S1, this is S2, 1 and 2. Okay, initially, and it's connected to an AC source. Okay, here we had a shaft, no, for measuring the linear displacement. When it is moving, this is a null position, and something like this is a null position, and when there is a movement in the up region or in the down region, that is it's either in the negative or in the forward direction, then you will have a displacement occurring over there in the shaft, and we will be able to detect this displacement depending upon the movement, either it is in the from the null position, whether it is moving away or towards the null position. That is, it will come something like this. It will be have connected this like, and we will connect like this, and we will take the output in this manner, and this will give you the output like this. Yeah, but how we are getting? We will getting it like S2 minus S1, this 2 S20 and S21. If it is equal, then it will become S21 equal to S22, then it is a null position. If it is the S11 is greater, then it is in the other direction. S22 is greater, then it is in the other direction. Like this, we have seen the principle behind the linear variable differential transformer and how it is measuring the linear displacement. And now we have as we have seen in the resistance potentiometers or in the resistance based transducers, here in the induction based transducers also we have the rotary displacement or angular displacement measurement. We have the angular displacement measurement. So here in the angular displacement measurement, instead of having a shaft, this shaft is being replaced by a circular camshaft. It's a linear shaft. Here you can imagine something like a camshaft which is rotatory in nature at the center. Okay, and the arrangement is the same, just it is having a camshaft which is connected at the center and it can rotate. Okay, when it is at null position, it is at this point and there is no cutting of magnetic flux. Okay, and when it starts to rotate, depending upon the amount of angular displacement or the angular movement that it has happened, the amount of voltage will vary. That's all is the principle. Okay, this is called as a rotary RVDT. You can simply take it as rotary VDT, that is variable differential transformer. Okay, so again I explain the principle. You have a primary winding, you have two secondary windings, and in between you had a shaft or a linear moving shaft in LVDT. Here you have a rotating camshaft in between, and that cuts the magnetic flux which changes the mutual inductance and you get the output. Okay, so this is the RVDT are the rotatory variable differential transformers working. Okay, so this is the basic principle behind a measurement of linear and angular displacement in our induction based principles. We also have included induction potentiometer. This potentiometer concept is very similar to our self inductance principle. You have a coil, okay, and we are measuring it, and you have again a slider or a rod like construction. You are giving in some voltage. This is input, and you are measuring the voltage here. Like the similar resistance principle, here you are giving in a voltage and measuring the inductance produced because of the movement here. What is happening, because it's a coil which is bound heavily, not like the resistance coil. Hence, because of the mutual self inductance change, there occurs a change in voltage depending upon the slider movement. Either it is moving in the one direction or in the other direction, depending upon the slider movement. This is happening, and you get the output. And this kind of a construction is called as induction based potentiometer or induction potentiometer, which is used to measure the linear variable displacement. Linear displacement measurement. Okay, so we have seen the induction potentiometer and the RVDT here. Okay, next comes a very important topic, that is synchros. What are synchros and why this synchros come into picture in induction based transducers? These synchros are actuator based mechanisms more than a sensing mechanism, okay, and it is used in heavily in many different kinds of applications, okay, and it is not a typical sensing based mechanism. It is more into a electrical machine construction. Immediately when I talk about electrical machine construction, what you get in mind? You should immediately get in mind about a DC motor or an AC motor, yeah, which is used for generating power. Then it is a generator, or else if you are going to give in power, it will rotate the shaft. Okay, so these are the two kinds of some mechanisms that you can remember: a DC motor or an AC motor or a generator can be remembered, and a Y connection, star connection, delta connection, everything you have studied in your circuit analysis. And all these principles are going to get involved in this synchros, which are induction transducers and actuators. First, let me first come inside the first part of the synchros, that is the driving mechanism or the transduction mechanism. Okay, then you have the next part. The synchros first has a transduction mechanism, then the actuation mechanism. Transduction mechanism is you are giving in a change and that is converting to electrical energy, and in the actuation mechanism the inverse is happening, that it is the electrical mechanism is taken in and then it is converted to the change. It's happening here in the synchros. We have the rotary displacement as the input, and that is the transduction, and at the other end you have this rotary displacement which is converted into electrical input, is converted into again the displacement. Okay, this is the basic principle behind the synchros. Now I come inside the details. There are two types of basically synchros. One is error detection or control synchros. Second one is torque controlled or transmission synchros. These torque transmission synchros is for moving small voltages and displacements. This error detection or the control synchros are for major torque movements and for some error detection mechanisms, as the name implies. Now first we will look into the error detection synchros. Error detection synchros. Okay. First we will see the transduction, how it is happening. You have a AC generator. The construction is the AC generator. Just I draw roughly. You have a stator part. Okay, and then you have a rotor part. Okay, you have a stator part and a rotor part. This is stator, this is the rotor. Okay, here you are giving in the displacement, okay, inside through the rotor, and you are able to get the voltage is the output what you get. Okay, then this output is taken through a line, okay, and it's connected to the next region. You can imagine the same kind of a construction, okay, and it is taken to the other side. Then what will happen? It will now behave like this is a generator. This is an AC generator. This is the transducer, acts like a transducer. The other side has an AC motor, which is the actuator, which converts the electrical signal into the displacement what you have given here. Okay, when you are going to rotate the shaft, then you are going to get the electrical signal, and that signal is transmitted through a line, and then that line gives the power to the AC motor, and the motor rotates. Okay, this is what the principle of the whole synchro. Okay, I simply draw a diagram for you. This is the synchro setup. You just put in all these mechanisms here. Okay, it's connected in the star connection. Okay, then at the other side you have the transformer section which transforms this, which brushes. Okay, this is the final thing. This is the input, and here you can get the see the output outside. So this is the final thing what you see in the synchros. One is the error detection type and the torque type. In the error detection type, now you are going to give an angular displacement, and this angular displacement is transferred to the other side. Now this is a very long line, and it is now transferred. Okay, where this kind of mechanisms are implied is the place where this movement of this rotor, where it is acts like an actuator, is connected to a load. You can imagine again this is connected to a cylinder, a steel cylinder is connected where you need to move the steel cylinder. So this is a load. Okay, this is a load. Now this displacement what you are precisely giving here for the input, that is the transducer input, is being transferred to the load here. This is what happens actually in the error detection or transmissions control synchros. This is what happens where you are giving in an angular displacement and it is transferred to the other end and it is given to the load to drive the load precisely as given in the input section. Okay, this is what exactly happens. And then there is going to be a loss in the line, but for the amount of input what you have given, there's going to be a loss that also can be detected here at the other end. So only hence it has the name error detection circuit. The next comes the torque detection synchro. The torque detection or the transmission synchro. Okay, this torque transmission synchro is connected to an AC line like this, something like this is connected. Again, it's imagine all this motor and the stator setups here. This is an AC line. Okay, here again, okay, when there is a displacement given there and then there is no synchronization between these two kind of the transducer and the this is the transducer and the actuator motors. When there is, then there will be a zero correlation or a zero correction will be happening. Okay, when there is a small disturbance happening over there, then there will be a change and you can measure the displacement happening. What is the main difference between the torque transmission and the error detection of the control is, here we are not going to connect any kind of load to the actuator. It's mainly used for detecting small and very precise measurements. That is the main aim of this torque transmission synchros. Okay, so that is the main aim between the error detection synchros and the torque transmission synchros. So the final section deals with resolvers. What are resolvers? You will see now. Previously, in the previous chapter or our previous unit, we have seen about the synchros. There are two different kinds of synchros. One is the error detection type and the other one is torque transmission type. And here it is the next one is about the resolvers. Here in the resolver section, the previous one is used for angular displacement measurement only. Okay, but here the application goes to, it's not only for angular displacement, it detects the angular displacement and splits into a Cartesian coordinate, something like a sine and a cos waveform. Is two types of transmissions can be done immediately with a displacement what you are giving in there inside. This is the very special type of an instrument or a machine, as we can say, because it's an electrical machine construction and it works in the principles of, we are giving in an angular displacement and it splits into sine and a cosine waveform and we get, because in all our previous application we are giving in an AC signal and we are getting the same kind of AC signal without any phase shift. Yeah, but here there is going to be a Cartesian shift, that is the cosine waveform will occur when you give an angular displacement, and when we are giving only a sine waveform of the 90-degree shift, then it will make a reverse shift of cosine waveform will be occurring, and it is applied in many different kinds of applications. Okay, that we will see now. First I will show you the construction. Here we have a stator windings. It is again a round. I just leave you all these things. A round will be there at the center. You have the stator, but the windings will be something like this. You have a stator winding like this, and then a rotor winding will be in this fashion. See, okay, a rotor winding in this fashion. Okay, so this is something like R1, R2, R3, R4. This is S1, S3, S2, S4. Okay, these are different kinds of inputs and outputs that we can receive it from the stator and the rotor, and the rotor rotates with an angular displacement that we give inside, and finally it produces a sine waveform sine theta and a cosine waveform cos theta. Depending upon the theta is our, where theta is the angular displacement that we have given here for our movement of the rotor. This is the main principle to understand. We are giving in an angular displacement, and the voltage that you get from the stator is having a sine waveform and also a cosine waveform. Okay, this is the basic principle of a resolver, and there are two classification of the resolvers. One is computing resolvers. The second one is synchro resolvers. Typically, the computing resolvers are used for, typically when you give an angular displacement, that will generate a sine, cosine and a tangent functions. Sine, cos and a tan functions will be generated. But a synchro resolver can be used. Now you can even take it for this previous synchros, okay, and it can be used in pulse modulation, phase shifting, etc. There are many different kinds of communication based applications which can be taken for the resolvers in conditions. As I told you, now we have taken the resolvers, which is a special instrument or a machine which is taken as an actuator, but the input that is given here is only a transduction mechanism. We are giving in an angular displacement and it is converted to a sine and a cosine waveform here. That's what you see here. Thank you very much, and we will meet you in the next class with capacitive transducers.